Hello, good morning. We are going to look at adding and subtracting fractions that have different denominators. So this here is an example of two fractions that don't have the same denominators. So the 8 and the 4 are different, and what that means is that if we want to add them together, we need to change one of them or both of them. It just depends. So changing one of them is less maths, changing both of them is more maths, but we should still get the same answer. Okay, what we are looking for is a number that they both fit into. So what number will they both fit into? And it's worth trying this number first, because 8 will always fit into 8, and it's just a matter of whether this number fits into it too. It's a big question. Sometimes it does, sometimes it doesn't. In this case, it does. So 4 fits into 8 and 8 fits into 8. We won't have to change this denominator. It can stay the same, which is lucky. It does, however, mean that we need to change the 4. We need to make it an 8 because these denominators need to be the same. So what would we do to 4 to make it 8? And the answer is multiply it by 2. So our new sum is 8 over 4 plus something over 8. So what did we do to this number to make it 8? We timesed it by 2. And we know with fractions that what we do to the bottom, we have to do to the top. So if we times the bottom by 2, we need to make the top 2 times larger as well. So 4 plus 8 plus 2/8. Even if you have a look, this is quite a simple example. 4/8 is a half, and an equivalent fraction of a quarter is actually 2/8. So we haven't changed the fraction. All we've done is we've made an equivalent fraction with the same denominator. We know that when we add, we have to keep the denominator the same. I'm running out of room. We know when we add fractions, these stay the same, and we add what's on top. Once you get an answer, you do need to simplify it. Okay, so 6 over 8 is 3 over 4. All right, I'm going to do another 2 examples because I know that there's a fair bit going on there. Okay, so we're trying to add 3/4 and 1/3 together, and because the denominators are different, we need to change them so that they are the same. You might have to change one, or you might have to change both. It just depends. This is an example of a question where you have to change both. 3 doesn't fit into 4. 4 fits into 4, but 3 doesn't. So what that means is both of these will have to change. What number fits into both 3 and 4? That's the question. So 4 fits into 8, 3 fits into 9, 4 doesn't fit into 9, 3 fits into 12, and 4 fits into 12. Good, so we found a number, 12. 4 fits into 12 and 3 fits into 12. You'll notice that if you multiply them together, you do find a number that they both fit into. Good, so the lowest number is 12. Both denominators fit into 12. Both denominators fit into 36. Both denominators fit into 72. Both denominators fit into 144. But the lowest number is 12. So how did we change this 4 and make it a 12? We times it by 3. So how did we change this 4 and make it a 12? We times it by 3. So we have to do that to the top number as well. If you times the bottom number by 3, you times the top number by 3. How did we change this 3 and make it a 12? We times it by 4. So we have to times the numerator by 4 as well. Nine plus 4 is 13. Can you please make sure that you're changing that to a mixed number? A mixed number. You'll notice there that the numerator is larger than the denominator. So it's actually 1 whole and 1/12.